Ever feel like you're reinventing the wheel every time you sit down to code?
Oh, tell me about it.
Like you're solving the same problems over and over again?
Yeah,
Well, that's where design patterns come in, right?
exactly.
It's like they're not just diagrams and fancy names. They're like having a toolbox full of these pre-engineered solutions for common object-oriented design problems.
Mm-hmm.
And so for this deep dive, we're cracking open the famous Gang of Four book,
Oh, yeah.
design patterns, elements of reusable object-oriented software
Right.
to explore some of these patterns and see how they can make our lives as developers so much easier.
What I think is so fascinating about design patterns is that they're really capturing this like collective wisdom of, really experienced developers.
Yeah.
They're not just about reusing code, but they're about reusing design, which is, like a much more powerful concept.
So instead of starting from scratch every time, we can leverage these like proven solutions and focus on the unique aspects of our projects.
Exactly. Design patterns are like blueprints that guide us towards creating, flexible, maintainable, scalable software.
Yeah.
They help us identify those hidden abstractions and opportunities for encapsulating concepts.
Okay, so let's get specific. Can you walk me through like how a design pattern might help solve a real world problem?
Sure. Let's say you're building an e-commerce platform.
Okay.
One challenge you might face is how to handle all those different payment gateways.
Yeah.
You could end up with this like tangled mess of if-else statements, right, to handle each gateway's specific API.
And that would be a total nightmare to maintain, especially if you need to add new gateways down the road.
Precisely. The strategy pattern provides a much more elegant solution. It lets you encapsulate each payment gateway as a separate strategy object. This way you can easily swap in and out different gateways without modifying that core payment processing logic.
So it's like having interchangeable modules for each payment method.
Exactly.
Makes sense. But how do we know which pattern to use for a given problem? I mean, there are so many to choose from.
Right. That's where understanding the intent of each pattern comes in.
Okay.
Let's dive into a few examples. We can start with some structural patterns, which focus on how objects are composed.
Okay.
The adapter pattern, for example.
Okay.
It acts like a diplomatic envoy, smoothing over differences between systems without forcing major changes on either side.
So if I wanted to integrate a legacy system that uses a completely different interface, I could use an adapter to kind of bridge the gap without having to rewrite either system.
Exactly. It's a lifesaver when you need to make incompatible systems work together.
Wow.
On the other hand, the facade pattern,
Right.
that simplifies interaction with complex subsystems. Think of a compiler with its scanners, parsers, and code generators.
Trying to use all those components directly would be incredibly overwhelming.
Right. A facade pattern provides a simplified interface, hides all that complexity. It's like having a concierge at a hotel who handles all the details for you.
Okay, those are some solid examples of how structural patterns can make our lives easier. But what about performance? Is there a pattern that can help us optimize for efficiency?
Absolutely. The flyweight pattern is all about sharing objects to reduce memory usage. Think of a text editor with potentially millions of characters.
Creating a separate object for each character would be incredibly inefficient.
Exactly. The flyweight pattern lets us share objects for each unique character, so drastically reducing memory consumption.
Okay, that's pretty clever.
Mm-hmm.
It seems like a lot of these patterns are about finding the right balance between flexibility, maintainability, and performance.
You're absolutely right. Design patterns aren't just about applying a specific solution, but understanding the trade-offs involved and choosing the best approach for that particular situation.
Now, I'm curious about this proxy pattern. It sounds a bit mysterious. What's the deal with that one?
The proxy pattern is all about controlling access to an object.
Oh.
Imagine you have a large image that takes a long time to load.
So instead of making the user wait for the entire image to load, we could display a low-resolution placeholder first.
That's a perfect example. The placeholder image acts as a proxy, standing in for the real image until it's fully loaded.
Oh.
It's like having a personal assistant who screens your calls and only lets the important ones through.
Okay, I'm starting to get a feel for these patterns.
Yeah.
They're like secret weapons for building better software. Let's talk about the command pattern next.
Okay.
What are some of its superpowers?
The command pattern encapsulates a request as an object.
Okay.
It's incredibly useful for implementing features like underrato.
Okay.
Think of a text editor where each action like typing, deleting, or pasting is a command.
So we can store these commands as objects and create a history list for under-row functionality.
Precisely. It also allows for logging, queuing, and other manipulations of commands, making the system much more robust.
All right, we've covered adapter, facade, flyweight, proxy, and command so far.
It's a lot. Yeah.
Are you starting to see how these patterns provide a higher level of thinking about design?
Absolutely. They offer a shared vocabulary and a set of proven solutions that can dramatically improve the quality of our software. But we've only just scratched the surface.
Right.
There are many more patterns to explore.
Well, let's keep this deep dive going. We'll uncover more of these design gems in the next part.
Welcome back. You're doing a fantastic job keeping up with these design patterns.
Thanks.
I mean, they can be a bit like learning a whole new language.
Oh, yeah, for sure.
But once you grasp the concepts, it's like unlocking a whole new level of coding fluency.
I'm starting to see that. It's
Yeah.
amazing how these patterns can take these complex problems and make our code so much more elegant and robust. I'm ready for more. What other design gems are we going to unearth today?
Let's shift our focus to creational patterns,
Okay.
which deal with object creation mechanisms. These patterns provide ways to instantiate objects in a flexible and maintainable manner.
Mm-hmm.
One of my favorites is the builder pattern. It separates the construction of a complex object from its representation, allowing the same construction process to create different variations.
Okay, that sounds intriguing, but I'm not quite visualizing it.
Yeah.
Could you give me like a real-world scenario where the builder pattern shines?
Sure. Imagine you're building a pizza ordering app.
Okay.
You could have different types of pizzas with various crusts, sauces, and toppings.
And using the builder pattern, we could create a separate builder for each type of pizza, like a margarita builder, a pepperoni builder, and so on.
You got it. Each builder would encapsulate the steps for creating that specific type of pizza. This way you can easily add new pizza types without modifying that core pizza creation logic.
So it's like having a specialized chef for each type of pizza,
Right.
ensuring that each one is made to perfection. I'm starting to see how this pattern can really streamline the process of creating these complex objects.
Yeah.
What other creational patterns should we add to our toolbox?
Let's talk about the factory method pattern. This pattern defines an interface for creating objects, but lets subclasses decide which class to instantiate.
Okay, that sounds almost like a magic trick. How does that even work in practice?
It's all about delegation and abstraction. Imagine you're building a document editor.
Okay.
You could have different types of documents, like text documents, spreadsheets, and presentations.
I wouldn't want to hard code the creation of each document type in my main application logic, right?
Exactly. The factory method pattern allows you to define a base class for creating documents, but then let subclasses decide which specific type of document to create.
So if I want to add a new document type, I just create a new subclass that implements the factory method for my new document type.
You're getting it.
Nice.
This pattern makes adding new features incredibly easy and avoids modifying existing code, which is always a good practice.
I'm seeing a common theme here. A lot of these design patterns are about making code more flexible, maintainable, and extensible.
You're absolutely right. They're
Yeah.
like investments in the long-term health of your code base.
That's a good way to put it.
Now let's explore the prototype pattern,
Okay.
which allows you to create new objects by copying or cloning existing ones.
So instead of building objects from scratch every time, we can just duplicate existing ones and modify them as needed.
Precisely. Imagine you're developing a game with different types of enemies.
Okay.
You could create a prototype for each enemy type and then clone those prototypes to quickly populate your game world.
That would save a ton of time and effort, especially if the enemies have complex initialization procedures.
Yeah,
So the prototype pattern is all about efficiency and code reuse.
exactly. It's particularly useful when creating objects is a resource-intensive operation. Speaking of efficiency,
Right.
let's talk about the singleton pattern, which ensures that a class has only one instance and provides a global point of access to it.
Now that sounds a bit restrictive. Why would I want to limit a class to just one instance?
There are certain situations where it's crucial to have a single point of control. Think of a logging system or a database connection pool.
Ah, those are great examples. You wouldn't want multiple instances of a logger writing to the same file or multiple connections to the database creating conflicts.
Exactly. The singleton pattern ensures that there's only one instance of these critical components, preventing potential issues and simplifying resource management.
Okay, I'm convinced. The singleton pattern definitely has its place in the world of good software design. But I'm curious, some developers argue that it can lead to tight coupling and make testing more difficult. What are your thoughts on that?
That's a valid concern. Like any tool, the singleton pattern has its trade-offs. It's important to use it judiciously and be aware of the potential downsides.
So far, we've explored a variety of creational patterns. It's amazing how each pattern addresses specific object creation challenges with such elegance and efficiency.
Yeah, it really is, yeah.
Are there any other creational patterns we should know about?
We've covered the key ones: builder, factory method, prototype, and singleton. Now let's venture into the realm of structural patterns, which focus on how objects are composed to form larger structures.
Okay.
We've already discussed the adapter and facade patterns, so let's move on to the bridge pattern. This pattern decouples an abstraction from its implementation so that the two can vary independently.
Decoupling seems to be a recurring theme in these design patterns.
Right.
What's the main benefit of decoupling in this context?
Flexibility and adaptability. Imagine you're developing a cross-platform application. You might need to support different windowing systems like Windows, Mac OS, and Linux.
And I wouldn't want my core application logic to be tightly coupled to a specific windowing system.
Precisely. The bridge pattern allows you to create a separate abstraction for a window and then have different implementations for each platform. This way you can easily switch between implementations without affecting the core logic.
So I could have a window class that defines the basic functionality of a window, and then have platform-specific subclasses like X window, Win32 window, and so on, each implementing the window interface in a platform-specific way.
That's a great way to visualize it. The bridge pattern allows you to create a bridge between the abstraction and its implementation, making your code more adaptable to changes and variations.
I'm starting to appreciate how these structural patterns can simplify complex systems and make our code more resilient to change.
Yeah.
What other structural gems are we going to discover today?
Let's dive into the composite pattern.
Okay.
This pattern lets you compose objects into tree structures to represent part-whole hierarchies. It allows clients to treat individual objects and compositions of objects uniformly.
Okay, I'm getting some mental imagery here. Is this like those organizational charts where you have individuals reporting to managers who in turn report to higher level managers?
That's a great analogy. Think of a graphical user interface. You have individual components like buttons, text fields, and checkboxes. But you can also group these components into panels or containers, which can themselves be grouped into larger containers, forming a hierarchy.
And using the composite pattern, I could treat these individual components and the composite structures in a similar way.
Exactly. The composite pattern allows you to create a tree-like structure where clients can interact with objects at different levels of the hierarchy without having to know the specific types of objects they're dealing with.
So I could have a function that draws a component, and it wouldn't matter if it was drawing a simple button or a complex panel containing multiple components.
You got it. The composite pattern simplifies client code and makes it easier to manage complex object structures. It's a powerful technique for representing hierarchical relationships.
This is fantastic. We've explored the bridge and composite patterns, both providing elegant solutions for structuring objects and building complex systems.
Yeah.
Are there any other structural patterns we should add to our arsenal?
Let's talk about the decorator pattern, which allows you to dynamically add responsibilities to an object without altering its structure.
Okay.
It's like adding toppings to a pizza. You start with a basic pizza crust, and then you can add different toppings without changing the fundamental nature of the pizza.
Okay, that analogy is making me hungry. But I'm also intrigued by how this pattern works in the context of software design.
Imagine you have a text view component in a user interface. You might want to add features to that text view, like borders, scroll bars, or spell checking.
And I wouldn't want to create separate subclasses for each combination of features.
Exactly. The decorator pattern lets you dynamically add these features by wrapping the text view object with decorator objects. Each decorator object adds a specific feature.
So I could have a border decorator that adds a border, a scroll bar decorator that adds scroll bars, and so on. And I can mix and match these decorators as needed.
You got it. The decorator pattern is a flexible and elegant way to extend the functionality of objects without creating a combinatorial explosion of subclasses.
This is mind-blowing. These design patterns are like puzzle pieces that fit together to create beautiful and well-structured software. I'm really feeling the power of these patterns. What other structural patterns await us?
We've already covered the facade and flyweight patterns, so that leaves us with just one more for this part of our deep dive: the proxy pattern.
Bring it on! I'm ready to conquer this pattern and add it to my design pattern arsenal.
You're doing great. The proxy pattern provides a surrogate or placeholder for another object to control access to it. It's like having a personal assistant who handles requests on your behalf.
Okay, that analogy is working for me. When would I actually use a proxy object in software design?
There are several common use cases. One is to provide lazy initialization.
So like when you have an object that's expensive to create and you only want to create it if it's actually needed?
Exactly. The proxy pattern lets you defer the object creation until it's absolutely necessary. Another use case is to control access to an object, perhaps for security reasons.
So like a bouncer at a club who checks your ID before letting you in?
Precisely. The proxy pattern can act as a gatekeeper, ensuring that only authorized clients can access the real object.
This is amazing. I'm starting to see these design patterns everywhere now. It's like I've unlocked a new level of perception in the world of software design. What other insights do you have in store for me in the final part of our deep dive? We've journeyed through creational and structural design patterns,
It's been quite a journey, yeah?
uncovering their elegance and power.
Mm-hmm.
Now I'm ready to explore the final frontier, behavioral patterns. What insights could you share about this category?
Behavioral patterns are all about communication and collaboration between objects.
Okay.
They define how objects interact and distribute responsibility. Think of them as the choreography of your software, ensuring that objects work together seamlessly.
Okay, I like that analogy.
Yeah.
So if structural patterns are the architecture of our software, behavioral patterns are the dance routines that bring it to life.
Precisely. Let's start with the chain of responsibility pattern, which avoids coupling the sender of a request to its receiver by giving multiple objects a chance to handle the request. The request gets passed along a chain of objects until one of them handles it.
That sounds a bit like a game of hot potato,
Yeah,
where the request is the potato and each object has a chance to catch it and handle it.
that's a great way to visualize it. Imagine you're building an online game with different types of characters: warriors, mages, and archers.
And each character type might have different abilities or actions they can perform.
Exactly. If a player issues a command, like attack, the request could be passed along a chain of character objects until a character with the attack ability handles it.
So a warrior would likely handle the attack request, while a mage might ignore it and pass it along to the next object in the chain.
You're getting it. The chain of responsibility pattern allows for flexible and dynamic handling of requests without tightly coupling the sender and receiver.
Okay, I'm adding the chain of responsibility pattern to my mental design pattern arsenal. What other behavioral gems await us?
Let's revisit the command pattern, which we touched on briefly before when discussing underrated functionality. Remember, it encapsulates a request as an object.
Ah, yes, the pattern that allows us to treat actions like objects,
Mm.
making it easy to implement features like underrated and command history.
Exactly. The beauty of the command pattern is that it decouples the object that invokes the command from the object that knows how to perform it. Think of a voice assistant like Alexa or Siri.
When I ask Alexa to play a song, my request is encapsulated as a command object.
Right.
And Alexa, acting as the invoker, delegates the actual playing of the song to a separate music player object.
That's a perfect example. The command pattern promotes flexibility and allows you to easily add new commands without modifying the invoker or the receiver.
Okay, the command pattern is definitely a powerful tool for building responsive and interactive systems. What other behavioral patterns should we explore?
Let's talk about the interpreter pattern,
Okay.
which represents the grammar of a language and provides an interpreter to deal with this grammar. It's like having a universal translator for different languages.
Okay, that analogy is working for me. But when would we actually use the interpreter pattern in real-world software development?
It's often used for domain-specific languages or for situations where you need to parse and interpret data in a specific format.
Okay.
Imagine you're building a system for creating custom reports.
And we could define a simple language for specifying the structure and content of the reports.
Exactly. The interpreter pattern would allow you to create an interpreter that understands this language and can generate the reports based on the user's specifications.
So instead of hard-coding the report generation logic, we could use the interpreter pattern to make the system much more flexible and customizable. That's pretty impressive.
It is. The interpreter pattern is a great choice when you need to define a custom language or interpret data in a specific format. Now let's revisit the iterator pattern, which provides a way to access elements of a collection without exposing its underlying representation.
Ah, the iterator pattern.
Yeah.
Our trusty guide for traversing data structures. It allows us to loop through elements without needing to know the internals of the collection.
You remember it well. The iterator pattern promotes loose coupling between the collection and the client code that uses it.
Right.
Think of a music playlist.
I can iterate through the songs in a playlist using a consistent interface, regardless of whether the playlist is implemented as an array, a linked list, or a database query.
Precisely. The iterator pattern provides a standardized way to access elements, making the code more readable, maintainable, and independent of the collection's implementation.
Okay, the iterator pattern is definitely a must-have in our design pattern toolbox. What's next on our behavioral pattern exploration?
Let's talk about the mediator pattern, which defines an object that encapsulates how a set of objects interact.
Okay.
It promotes loose coupling by keeping objects from referring to each other explicitly, and it lets you vary their interaction independently.
Okay, this one sounds a bit like a traffic controller, directing the flow of communication between objects and preventing them from colliding.
That's a great analogy. Imagine you're building an air traffic control system.
Okay.
You have multiple airplanes, and you need to coordinate their movements to avoid collisions.
Instead of having each airplane directly communicate with every other airplane, we could introduce a mediator object, the air traffic controller, to manage all the communication.
Exactly. The mediator pattern simplifies complex interactions and prevents objects from becoming tightly coupled. It's like having a central communication hub that keeps everything organized and flowing smoothly.
Okay, the mediator pattern is a powerful tool for managing complex systems with many interacting objects. What other behavioral patterns should we add to our repertoire?
Let's talk about the memento pattern, which captures and externalizes an object's internal state,
Okay.
allowing you to restore an object to a previous state without violating encapsulation. It's like having a time machine for your objects.
Okay, that sounds intriguing, but I'm not quite visualizing it. Can you paint me a picture of how it works in practice?
Imagine you're playing a video game, and you want to implement a save game feature.
The memento pattern could be used to capture the current state of the game, including the player's position, inventory, and progress.
Exactly. You could create a memento object that stores all this information.
Right.
Later, when the player loads the save game, you would use the memento to restore the game to its previous state.
So the memento pattern acts like a snapshot of the object's state,
Yeah.
allowing us to travel back in time and restore it later. That's a clever way to handle features like save load or Dorado.
It is. The memento pattern is all about preserving and restoring object states without exposing their internal details.
Okay, I'm adding the memento pattern to my growing collection of design pattern knowledge. What's next on our behavioral pattern journey?
We've already covered the observer and state patterns, so that leaves us with just one more behavioral pattern to discuss.
Okay.
The template method pattern.
Bring it on. I'm ready to complete our deep dive into the world of design patterns with this final gem.
The template method pattern defines the skeleton of an algorithm in an operation, deferring some steps to subclasses. It lets subclasses redefine certain steps of an algorithm without changing the algorithm's structure. Think of it as a blueprint for a process with some customizable steps.
Okay, so it's like a recipe for baking a cake, where you have the basic steps outlined, but you can customize the flavor or frosting based on your preference.
That's a delicious analogy.
Yeah.
Imagine you're building a framework for online quizzes.
Okay.
You could have a template method that defines the basic steps for conducting a quiz, presenting questions, collecting answers, grading the quiz, and displaying the results.
And then we could have subclasses that specialize in different types of quizzes, perhaps with variations in how questions are presented or how answers are evaluated.
You got it. The template method pattern allows you to define the overall structure of the algorithm while giving subclasses the flexibility to customize specific steps. It's a powerful technique for creating families of related algorithms.
This deep dive into design patterns has been an incredible journey. I'm amazed by how these patterns provide elegant solutions to common software design challenges, making our code more flexible, maintainable, and efficient.
It's been my pleasure to guide you through this exploration. And remember, design patterns are powerful tools, but they're not silver bullets.
Right.
It's important to understand their intent and use them judiciously.
Well said. I'll definitely keep that in mind as I continue my journey as a developer. To our listeners, I encourage you to dive into the world of design patterns. They're not just for experts. They're for anyone who wants to write better code. Keep learning, keep experimenting, and most importantly, keep having fun with it.